right, so let's look into a little bit what's going on with these dilations. First, let's start with a definition. So a dilation is just a transformation that increases or decreases the distance from some center. And essentially what this means is that with a dilation, we are either causing something to grow or to shrink, one of those two. And it's a transformation, which means it's just like those transformations that we saw before in that it's changing a figure. So just like translations, reflections, and rotations, this thing is changing something about a shape. However, it's not an isometry. All three of those that we discussed before were isometries because they didn't change the shape or the size of an object. They just changed its location. A dilation is very different from this. It won't change the shape, but it will change the size. So again, a dilation changes a shape's size, but not its shape. So things will still look like they did, just bigger or smaller. All right, let's talk about that bigger or smaller business. If the dilation makes the shape bigger, we call that type of dilation an enlargement, and if it makes it smaller, we call it a reduction. So every dilation that changes the size, that is, as long as you're not dilating so that it stays the same size, it's either going to be an enlargement or a reduction. So those are the two types of dilation. Enlargement makes things bigger, reduction makes them smaller. And the amount that the dilation changes the size is what we call the scale factor. And the scale factor is pretty easy if you just make sure to common sense this out. If we dilate something so that it's 2 times bigger than it used to be, the scale factor is 2. If it's 3 times as big as it used to be, the scale factor is 3. For a reduction, we're looking for numbers that are between 0 and 1. So if we want the thing to be half as big as it used to be, our scale factor is going to be 1/2. So again, if the scale factor is bigger than 1, it's an enlargement, and if it's less than 1, we're going to have a reduction. Notice that's less than 1 but greater than 0. All right, and last thing is how to find the scale factor of these. So when you have an image and a pre-image from a dilation, if you want to find the scale factor, all you have to do is pick some distance that's on the image and pre-image, and you want corresponding parts. And if you take the size of the image divided by the size of the pre-image, those numbers are going to give you the scale factor. And we'll practice some of that in some exercises later on.